Hello students, welcome back to the another session of our data structure journey. In this video, we are going to learn most commonly graph traversing algorithm, that is the breadth first search algorithm. Graph traversal is the process of traversing or visiting each and every node present inside a graph. There are two ways we can traverse the graph. First one is the depth first search, which is we are already covered in our previous video. We also did the implementation in the C language in last video. In this video, we are going to cover the breadth-first search algorithm. It is a recursive algorithm to search all the vertices or nodes present in a graph data structure. This algorithm can be used for the tree also. Whenever we go for breadth-first search algorithm, all the nodes can be represented as a visited or unvisited. Means we can say we classify all the nodes in a two-way. First one is the visited and another one is the unvisited. So in this graph, so this is a graph structure. Here A, B, C, D, E, F, G, H, I, all are nodes, and the association or link between two nodes is called as the edges. So these are the edges present inside the graph. What is our main objective? Main objective in this case that how we are able to visit all the node present inside the graph. As I have already told you right now that the algorithm divided all the node in the graph as a two category. First one is the visited, second one is the unvisited. So what is visited, what is unvisited? So here graph traverse mean visiting the node. We have to start from the starting node. Next question, which one is the starting node? Whether A, B, C, D. There are so many node or so many vertices is present. In case of given means in your question, if the starting node or starting point of the graph is given, for example, A is given, then what happened? You have to traverse from the A, or it is given that is the D, then we have to start the traversing from the D node. But if in your question there is no such type of information is given, that is starting node, then we have to select randomly any node and we have to perform the breadth first search node. So here, for example, we have to start from the A node. Then what is the algorithm of breadth first search algorithm? You start the traversing from the graph node, from the start node or vertex, and explore all the neighbor vertices. So all the neighbor means adjacent vertices. So for A, what are the possible edges is given? A to B, B to E, then A to C is given. So there are three possible ways present: A to B, A to C, A to C, A to E. So B, E, C. So these are the adjacent matrix to the A. After that, what happened? Once we explore all the nearby vertices, then we have to select the nearest one. Then we have to traverse all its neighbors. So this is the same sequence we have to follow until we are not reach the end of the graph. So here what happened whenever we explore. So the already explored vertex is called as the visited node or visited vertex. Unexplored node or unexplored vertices is called as the unvisited nodes. So here what happened, the queue data structure is used for the implementation case. So when deletion operation of a queue is called as the DQ. So this way we are insert the element, this is the deletion. And whenever a node is visited, we make as a visited node or explored node, and we are just writing here. So for example, we have to start from this node. So we are starting from A. So first we have to put the node or the vertex into the queue. After that, we have to explore all the nearby node whenever we perform the deletion. So step one, insertion, we insert storage. Then we have next step we have to delete. Whenever we are removing this element, we have to insert all the adjacent matrices. So all the adjacent nodes. Nodes, B is present, E is present, C is present. So whenever we make this one as a visited, we make the A as unvisited, then all the neighbor nodes. So B, E, C. One more thing here, that the sequence I can write down E, B, C or C, E, B, any sequence, but it is recommended that whenever you follow any sequence, you should make the same sequence. Or if it is given that you have to follow the alphabetically order, then from for the B, E, F, which one we have to select? We have to select the B. So here I make a sequence that is the B, E, any sequence. For example, I go for the alphabetically order. So here what happened? Whenever you go for sequence maintain, here the sequence should be maintained. Insertion is done on the basis of alphabetically. If we go for alphabetical, then what happened? Here it C should be present. So little bit changes we have to do. That is here C, here E should be present. It is alphabetically. So next iteration, what happened? We have to make this one as a B and we have to delete from the queue and put all the adjacent matrix into the queue. So here we have to remove. Once we remove this one, means all the this element shifted to the first position. So here this is the C, this is the E. Now what are the adjacent nodes? D is present, A is already visited, C is already for which node? B. A is already visited, E is already present inside the queue. Only D is present. So we have to insert the D. So whenever we insert the element, we have to perform the alphabetically order. Insertion should be done on the alphabetically order. So D we selected. After that, which element we have to remove? We have to remove the C. So here we remove the C. Whenever we remove the C, at that time what happened? So it will comes to here. This is D. After that, what are the adjacent to the E? Sorry, C. C, A is already visited. E is already present inside the queue. Only left, that is the F. So we have to put the F. So here what happened? Next iteration, we have to remove this one and we have to make the E node as a visited. So here what happened? We have to, this is D, this is F, because whenever element is deleted, then what happened? The one element is shifted to the previous node. Then what happened? E. For E, what are the adjacent matrices? Adjacent node is present. For E, A is visited, B is visited, D is already present, G is not visited, I is not visited, H is not visited, J also, sorry, this is J, this is I, is not visited. F were already present, C is already. So now this four element is accepted, each adjacent and acid unvisited or unexplored. Then we have to insert it. But whenever we are inserting with the queue, here we have to perform the alphabetical, because we are already mentioned that whenever we insert any data into the queue, it should be on the basis of alphabetically order. So here what happened? I, J, so G, H, I, J. So it will be store this value. Now we have to remove which element? D element. Whenever we remove the D element, at that time what happened? There is no adjacent is present because B is already visited. E is already visited. G is already present inside the queue. So there is nothing. So now here what happened? Here F is shifted, here G is present, here H, this is the I, then this is the J. So this is the sequence they follow. Once the element is deleted, it should be shifted to this position. Now we have to remove F, deletion should be done and put into the location. Then this element shifted to here. This is G, this is H, this is I, this is J. Then it remove one element, that is the G. After that, what happened? Here it will be shifted to H, I, then this is J. So the same sequence follow and all the element present inside the Q is deleted because after that there is no element is present. So this is the traversal. Means A to B, B to E, E to D, D to F, G, then H, then I, J, J. So how it's from traversing? A to B, B to C, then C to E, then it will go to C to E, then E to D, then D to F, then F to G, G to H, H to I to J. So we can think like that it is a level wise traverse. That's why BFS is also called as the level wise traverse. Next, what is the time complexity of this algorithm? So here the time complexity is the order of V plus E, where the V is the number of nodes and E is the number of edges. Space complexity of this algorithm is order of V. V is the number of nodes or vertices present inside the graph. So next, after the advantage of this algorithm, the solution we definitely find out by the BFF. If there is some solution is present, definitely we will get the solution. But in DFS, what happened? That is the depth first search. You may get, we may not get. But this algorithm guarantee that if there is a solution, then definitely it will find out. It will not get trapped blindly, which means unwanted node, it will not go for traversing. If there are more than one solution, then it will find the minimal step. Means minimum step we have to traverse to the reach a goal node. If there are more than one goal node is present and we are searching for a specific node, then what happened? This algorithm guarantees that we can able to reach to the goal with the minimal steps. But what are the disadvantages? It is a memory constant. Reason is that here what happened, each and every label node we are going to store. That's why the memory requirements is more compared to the depth first search. If there is a solution in far away, then it consumes time because if here it traverses the level by level, but it is if the solution is present far away, then depth first search if go to the that way, then they definitely will reach the goal very less time compared to the BFS. But if you go for BFS, then what happened? It will more consuming time. So these are the disadvantage of the BFS algorithm. Next, we have to know what are the application means where we can able to use it. In case of shortest path, unwanted graph, we can use for to calculate or find out the shortest path. In case of web crawler, we can use the explore the web pages level by level. In case of social network, it can be used to find out shortest paths such that we can able to get the degree of separation. It can use to send the information like the broadcast message to all nodes in the computer network. It also help to identify the connected component in the directed graph. It also used to find out whether any cycle is present inside the undirected graph or not. In case of P2P network, it can be used to find out all the node within a certain number of hoops. So these are the application we are also can use for the puzzle solve problems. We can able to use this algorithm. Hope you are able to understand the concept of breadth first search algorithm in a data structure. Thanks for watching the video. Please like, subscribe, share the channel. Thank you so much.